Hello students and welcome to lesson 4 on cube roots. Today's essential questions are, what are cubes, which you should already know, that is an exponent of 3, and also what are cube roots, which should be new for you in our focus today. Our second essential question is, how can cube roots be simplified? And third, how does this, meaning cube roots, relate to what I already know about square roots? So let's review before we start talking about cube roots what square roots are, because they are directly related. A square root is a number that when multiplied by itself results in the given radicand. So for instance, the square root of 9 is 3 because 3 times 3 is 9. Notice the 3 is multiplied twice to get the 9. And if you think about a square, this like a square shape, that makes sense because it has two dimensions, length and width. Square roots are known as radicals. Remember, the symbol is called a radical sign, and the number inside is called the radicand. We will see the radicand and the radical sign when we talk about cube roots. Now, there are two types of square roots that we've learned about. Perfect square roots, which we know are rational numbers, and non-perfect square roots, which are irrational numbers. Both types can be simplified, but just a little differently. Perfect square roots are simplified by writing the exact number that can be multiplied by itself to equal the original number. The square root of 9 has one exact number, which is 3, that can be multiplied by itself to equal that number. However, when we start talking about non-perfect square roots, which we know are irrational, meaning they equal a decimal that goes on forever without repeating, we have to estimate them or simplify them by removing the perfect square roots, any pairs, meaning 2 factors from the radicand. Now, you may remember we talked about the first 12 perfect square roots. Here you see the first 13. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6, the square root of 49 is 7, the square root of 64 is 8, the square root of 81 is 9, the square root of 100 is 10, the square root of 121 is 11, the square root of 144 is 12, the square root of 169 is 13, and the square root of 196 is 14. Now these are the first 14 perfect square roots. I ask you to know the first 12. It's nice to know the perfect square roots because then you know that everything in between is non-perfect or is irrational. For instance, the square root of 105 would be somewhere between 10 and 11. To simplify non-perfect square roots, remember, we learned to remove pairs of factors from the radicand. So for instance, if we have the square root of 20, we would rewrite the radicand as its prime factorization. We know that 20 is the same as 2 times 10, and that 10 is the same as 2 times 5. So we have the square root of 2 times 2 times 5. We would remove this pair of factors since it equals the square root of 4, and we know the square root of 4 is 2, so we can write a whole number instead of square rooting those two factors. And we have the 5 left over, so we would say this is 2 times the square root of 5. Let's do one more example like that. The square root of 250. We would first factor 250, which is 25 times 10. 25 is 5 times 5. 10 is 2 times 5. So we get 2 times 5 times 5 times 5. Rewriting the radicand as the prime factorization. 2 times 5 times 5 times 5. Remove any pairs of factors. The only pair we have is 5 times 5, we know that the square root of 25 is 5, so we get 5 times the square root of 2 times 5. And 2 times 5 is 10, so this is 5 times the square root of 10. This is very similar to what we'll do with cube roots. Now let's first talk about what cube roots are. A cube root is a number that when multiplied by itself 3 times results in the given radicand. So as you see in this example, the radicand is 27. We want to know the cubed root of that. That's how you would read that, the cubed root of 27. And it is 3 because 3 times 3 times 3 makes 27. 3 times 3 is 9, and 9 times 3 is 27. If you multiply 3 times, you will get 27. This is a perfect cubed root. Now let's get a little vocabulary. We already know that this is the radical sign. We know that this is the radicand. But what we don't know is what this cube is called, the cubed root. That is called the index. It tells you how many times you must multiply the number to get the radicand. This is called the index. It can be more than a cube, but we will only study squares and cubes, so you will only see a 3 as the index in this class. There are 2 types of cube roots, just like there are 2 types of square roots. There are perfect cubed roots and there are non-perfect cube roots. The perfect cube roots are rational and they will equal a whole number, and the non-perfect cube roots are irrational. They will equal a non-repeating, non-stopping decimal. Both, like square roots, can be simplified. Perfect cube roots by writing the exact number that can be multiplied by itself 3 times to equal the original number. This is very similar to square roots. And non-perfect cube roots can be simplified by removing perfect cube roots, triplets of factors from the radicand. So now there has to be 3 of the same factor to remove it from the radicand. Here you see a list of the first 10 perfect cube roots. The cubed root of 1 is 1. 1 times 1 times 1 equals 1. The cubed root of 8 is 2. 2 times 2 times 2 is 8. 2 times 2 is 4. Times 2 is 8. 3 is equal to the cubed root of 27. 3 times 3 times 3 makes 27. The cubed root of 64 is 4. The cubed root of 125 is 5. The cubed root of 216 is 6. The cubed root of 343 is 7. The cubed root of 512 is 8. The cubed root of 729 is 9. And the cubed root of 1,000 is 10. You could generate any of these 10 by multiplying the whole number 3 times in a row. For instance, 7 times 7 times 7 is 343. You can also remove triplets of factors. Now, this is a very similar process as to simplifying square roots. The only difference is in step 2, we need to look for triplets of factors, which means sets of 3, rather than pairs of factors, meaning 2. So our first step is going to be to rewrite the radicand as its prime factorization. So we need to factor 270. 270 ends with a 0, so I know I could factor it with 10 and 27. Now 10 is the same as 2 times 5, both of which are prime. 27 is 3 times 9. 3 is prime, 9 is not. 9 is the same as 3 times 3. So if we wrote our prime factorization, we would say 2 times 3 times 3 times 3, and there you see the triplet of factors, times 5. So we'll rewrite our cubed root of 270 as 2 times 3 times 3 times 3 times 5. That's our first step. Rewrite the radicand as its prime factorization. Our second step is going to be to look for the triplets of factors. Well, here you see a triplet of factors. 3 times 3 times 3, we learned on the last slide, is 27. The cubed root of 27, which is 3. So we can remove this triplet of factors by writing only 1 3 outside the cube root. Now notice there's no triplet of factors for the 2 and no triplet of factors for the 5, so they remain inside. 2 times 5. 2 times 5 simplifies. Step 4, simplify. 3 times the square root of 10. The cubed root of 10. The cubed root of 270 is the same as 3 times the cubed root of 10. Let's do another example. The cubed root of 3,000. The cubed root of 3,000. So first step is we need to write the radicand as its prime factorization. We have to factor 3,000. Let's do 3 times 1,000. 3 is prime, 1,000 is not. Let's do 1,000 as 10 times 100. 10 is the same as 2 times 5. 100 is the same as 2 times 50. We got some prime numbers here, we'll circle. 50 is the same as 5 times 10. 10 is the same as 2 times 5. So we have 2 times 2 times 2, there's 3 2's, times 3 times 5 times 5 times 5. That's the prime factorization. So we'll rewrite this cubed root as 2 times 2 times 2 times 3 times 5 times 5 times 5. That's step 1. Write the cubed root's radicand as its prime factorization. Step 2, identify any triplets of factors. Well, we have a triplet of 2's and we have a triplet of 5, and we can remove them from the radicand because they make perfect cubed roots. So instead of writing the cube root of 2 times 2 times 2, I can write the whole number 2. And instead of writing the cubed root of 5 times 5 times 5, I can multiply that 2 by the whole number 5 because this is a perfect cube root. The cube root symbol, or the radical sign, must stay because we have a 3 remaining that does not have any triplets of factors. Step 4, simplify. 2 times 5 is 10, so we get 10 times the cubed root of 3. The cubed root of 3,000 is the same as 10 times the cubed root of 3. Let's simplify the cubed root of 210. First, find its prime factorization. 21 times 10, 3 times 7, 2 times 5. So yeah, these are all prime numbers. So 210 is equal to 2 times 3 times 5 times 7. So we'll rewrite the radicand as its prime factorization. 2 times 3 times 5 times 7. Now, step 2. Look for any triplets of factors. Does this have any triplets of factors? No. Now, that's okay. All that means is it was already simplified. You cannot simplify this one any further. So the cubed root of 210 is already simplified.